Have you ever just stared into a campfire and wondered, what's actually going on in there? We see fire all the time, but we kind of take it for granted. Well, today we're going to pull back the curtain on the amazing science behind something we think we know so well, burning, or as scientists call it, combustion.
So, let's start with a little warm-up question. Think about petrol for your car, a log for a fireplace, and the natural gas that cooks your dinner. I mean, they seem totally different, right? But what's the one big thing that links them all together?
You got it. They're all fuels. And when you get right down to it, a fuel is just stuff that we can burn to get energy out of. And that energy, whether it's heat or light or motion, that's what we're really after.
Now, we all call it burning, but if you want to sound like a scientist, the word you're looking for is combustion. They mean the exact same thing, so don't let the fancy word fool you. When I say combustion, just picture something burning. Simple as that.
Okay, so what does it actually take to make a fire? Well, turns out it's kind of like a recipe. A really simple one with just 3 key ingredients. And the best way to remember it is with something called the fire triangle. So here they are, the 3 sides of our triangle. First up, you need fuel, the thing that's actually going to burn, like wood or paper. Then you need oxygen, which, lucky for us, is pretty much everywhere in the air. And finally, you need heat, that initial spark or flame to get the whole party started. And here is the absolute key, summed up perfectly by Dr. Tim Gregory. You need all 3 at the same time, no exceptions. You could have a giant pile of wood and all the air in the world, but without that initial heat, nothing. Take away just one of those sides, and any fire that's already going, well, it's going out.
This brings up a really cool point, right? If we know exactly what a fire needs to live, doesn't that mean we also know exactly how to, kill it? Yep, all firefighting is the science of breaking that fire triangle. Think about it. When you throw a damp cloth over a flaming pan, you're not trying to make it wet. You're cutting off its oxygen supply. When a firefighter soaks a building with a hose, the main goal is to suck all the heat out of the reaction. And of course, when a campfire burns through all its logs, it's out of fuel. The fire starves and dies.
Okay, so we've got the big picture ingredients down. But now let's zoom way in, like down to the molecular level. What is actually going on with the tiny little atoms and molecules when something is burning? The secret sauce here is a chemical reaction called oxidation. And I know it sounds kind of technical, but all it really means is that a substance is grabbing onto and combining with oxygen atoms. Combustion is just a really, really fast and dramatic version of that. So let's put it all together then. In a combustion reaction, our fuel mashes up with oxygen. They have a big chemical rearrangeroo, and bam! Out comes that useful energy that we see as heat and light. Now, before we look at a real chemical equation, we need to learn 2 little words. The stuff you start with, in our case, the fuel and the oxygen, are called the reactants. And the new stuff that gets made in the reaction, those are the products. It's easy to remember. Reactants react to produce products.
All right, so now we know the lingo. Let's see how scientists actually write this recipe down. They use something called a chemical equation, which is really just their fancy shorthand for explaining exactly what goes in and what comes out.
And to make this feel real, let's use a fuel we're all familiar with. Butane. The stuff in your gas barbecue. Its chemical name is C4H10, which just tells us it's built from carbon and hydrogen atoms. The easiest way to write it out is just using words. On the left, you've got our reactants, butane plus oxygen. That little arrow in the middle just means turns into or produces. And on the right, we get our products, carbon dioxide and water.
So just to be super clear, here are our reactants again, the stuff we started with, butane and oxygen. And here's the brand new stuff that was created in the fire, our products, carbon dioxide and water. Okay, and this is what it looks like in full scientific shorthand. Now, don't let all the letters and numbers freak you out. It's telling the exact same story as the word equation. The numbers are just there to make sure every single atom is accounted for. In chemistry, you can't create or destroy atoms. You can only rearrange them. So we've got the science down, but why does any of this really matter in our everyday lives? Well, let's zoom back out and look at the massive impact combustion has on our world, both the amazing power it gives us and the consequences it leaves behind. The truth is, we rely on combustion for, pretty much everything. It's moving our cars, it's heating our houses, it's generating almost all of our electricity. But as you can see,
every single one of these amazing uses has a flip side, a consequence.
And that main byproduct, especially from fuels like petrol and gas, is carbon dioxide. You know it as CO2. And CO2 is a greenhouse gas, which means it traps heat in our atmosphere. And that buildup is a huge driver of global warming.
And think about one of the other products we just talked about, water, or H2O. That little 2 means there are 2 hydrogen atoms for every 1 oxygen atom. This is a fundamental building block of our world, and it's created in almost every fire you see, from a candle flame to a car engine. It's a reminder that these reactions aren't just creating energy, they're creating brand new molecules too.
So, really, this is the massive challenge we're all facing. We have literally built our entire modern world on the energy we get from combustion. So the big question for all of us, for our future, is how do we manage what this incredible, powerful, and ancient chemical reaction leaves behind?